Okay, right. So now let's solve this problem, right? Now this is actually related with dimensional analysis, right? So now it says that the critical depth YCR, that is the critical depth, right, in a V-shaped channel depends upon the discharge Q and some other parameters as acceleration due to gravity and vertex angle theta, right? Now that's the problem, right? The critical depth Y critical in a V-shaped channel, right, depends upon the discharge Q, right, and some other parameters as acceleration due to gravity and the vertex angle, right. So now here there are two questions that they are asking. So they ask how vertex angle theta is made. In other words, how vertex angle theta is, you can say, measured, right? How that angle is measured, right? And derive an equation for y. That means we have to derive an equation for the critical depth. So let's see how to do that, right? So now here there are four basic parameters, right? That's right. Before that, we have to go to the first question. What is the first question? How the angle is made, right? So the answer is very simple, right? So that is actually the angle theta is made by the two side walls of the channel, right? The answer is that angle theta is made, right, is made with the two side walls of the channel, right? Okay, fine. Now next part, derive an equation, right, by using the knowledge in dimensional analysis, right? So now let's first write the basic parameters. So let's put serial number 1, serial number 2, 3 and 4. The first one, critical depth, okay, and let's write the symbol, right, symbol and the dimensions, right, okay. So critical depth, discharge, what is the symbol? Q. Critical depth is YCR, and acceleration due to gravity, acceleration due to gravity, let's say that is G, and vertex angle, okay, that is theta. Vertex angle is theta, right? Okay. So what is the dimension of critical depth? It's a length, right? So capital L. Discharge is a flow rate, meter cubes per second, right, in units. So it will be meter cube, L cube T minus 1. Okay, is that clear? The L cube T minus 1. And G, we know the units ms minus 2. So then dimensions will be L T minus 2, right? So now if you are going to consider the vertex angle, like dimensionless, no dimensions, right? So then no dimensions means m to the power 0, L to the power 0, T to the power 0, right? So what is MLT? MLT are the basic dimensions for mass, length and time, right? So now, how many parameters are there? How many parameters that we have in the problem? See, parameter 1, 2, 3, 4. So that means n equals 4. Okay. Then now how many basic dimensions are used in the problem? Right now, be very careful. We have three basic dimensions. That is okay, mass, length and time. But among those three basic dimensions, right? So how many basic dimensions are used in the problem? So the answer is 2. See, L is used and T is used. See, even though M is there, M is not used. So used basic dimensions, right, or the basic dimensions that are used, so that is M. So M equals 2, right? So then now there's a special equation, right, that is given by n minus m, right? There is a special equation that is n minus m. So what is n? 4. M2, 4 minus 2, the answer is 2. Actually, this equation gives the number of dimensionless, don't go after spellings, okay? I want to be very quick. The number of dimensionless parameters. or quantities, right? So n minus n gives the number of dimensionless parameters. Okay, fine. So that is 2. Now be very careful that in this problem that we already know that if I'm going to consider this guy vertex angle theta, it is dimensionless because it has no dimensions, right? We already know that, but this equation tells that we have 2 dimensionless quantities, right? So one is known. So what will be the other one? Shall I erase the problem here? So what is the other dimensionless quantity? So let's say that is phi 2, right? That is phi 2. So now we say there is a special way of solving that. So now phi 2 we are going to write by using other 3. Now see, if you are going to consider these 4 parameters, one parameter is there that has no dimensions, right? And we have 3 parameters that are having dimensions, right? So now we are going to find the other remaining dimensionless quantity by using, okay, right? So now we know that there are 2 dimensionless quantities, right? What is one quantity? The one quantity is the vertex angle, right? Vertex angle theta, right? So this is dimensionless, right? What is the other dimensionless quantity? That is phi 2, right? So that we write in a format like this, right? And we know that in this problem there are 3 quantities, right? There are 3 quantities that have dimensions, right? So what are those 3 quantities? One is the flow rate, right? And other one is the critical depth, right? The other one is the acceleration due to gravity. You know that, right? Y critical, the critical depth, right? And the other one is the acceleration due to gravity, which is G, and the other one is the flow rate, which is Q. Okay, right. So now let's write this phi 2 in a format like let's say Q, right? Actually here Q means actually the dimension of Q. That is what we have to consider, right? Okay, so let's consider like that. The dimension of the flow rate to the power x, right? Then the dimension of the acceleration due to gravity, so within square brackets I will write g to the power y, and just write the other quantity, right? Just write the other quantity that is having dimensions, right? Y critical, right? Okay, then sometimes you might be asking a question, right? So why I didn't consider any sort of a power to that? It's okay, but you can even consider like that also, right? But so far just want to consider this format, right? Okay, so what is that? Again I'm telling that phi 2, this is second dimensionless quantity, right? Okay, equals flow rate to the power x and the acceleration due to gravity to the power y times the critical depth. Okay, now phi 2 equals, what is q? That is the flow rate, right? So we know that what is the unit? The unit is meter cube per second, right? So what would be the dimensions, right? L cube t minus 1 to the power x. Agree? Then g is the acceleration due to gravity. It is very easy to remember the dimensions, right, with respect to the units, right? Because now the fact is like units are very much familiar to us than the dimensions, right? So it is okay, first you consider the units, right? Okay, then from the units you can easily go for the dimensions, right? So that is much more easier. Meters per second squared, right? So then the dimensions would be ms minus 2 will be the unit, right? So then L e minus 2, check again, to the power y, right? So then the critical depth, that is a depth, something like a length, right? L, right? It's a length, right? So then what will be the dimension for a length? That is L. Okay, fine. So now simplify that. Okay, so here what do you have? L to the power 3. Here we have power x. So what will be the total power? 3x. And from here you are getting, see, L here, and then power y there, then 3x plus y, right? Then we will separately consider like one by one. Okay, then L to which power, then t to which power, so like that. So here we have 3x, then plus y, here we have L, so then the power is positive 1. Okay, L to the power 3x plus y plus 1. Agree? Okay. Then what is the next one? Time t. T, here we have minus 1 times x minus 2y. Is that all? Yes. Right. Then focus phi 2, the left hand side. Now see, what is this phi 2? Phi 2 is actually dimensionless, right? It has no dimensions. Right? Dimensionless quantity, the second dimensionless quantity. So this we will write in this format. Now here there will be no dimensions. So let's write m to the power 0, L to the power 0, then t to the power 0, right? So now you can match the dimensions individually. Let's match the dimensions of L. So what is the power that we have here? L to the power 0. So then here we have 0. So if you are going to consider the dimensions of length, so then you can say here the power is 0. 0 equals 3x plus y plus 1. So that is the equation number 1. Agree? Then considering the dimensions of time, right? If you are going to consider the dimensions of time, then here also we have 0 equals minus x minus 2y. This is the equation number 2, right? So let's solve this, right? Okay, simplifications, right? Very easy. Considering equation number 2, minus x minus 2y equals 0. That means x equals minus 2y. Then use this result in equation number 1 there. So then equation number 1, 0 equals 3 times x means 3 times minus 2y, minus 6y plus y plus 1 minus 5y plus 1. So if you simplify that, you will be getting y equals 1 over 5. Agree? Right. So if y equals 1 over 5, then what is x? Then x will be minus 2 divided by 5. Agree? Right. So now we have evaluated that x equals minus 2 divided by 5, right? Then what is y? Y equals 1 over 5. Okay. And we know that this is the way that we have considered, right? Phi 2 equals, right, flow rate q to the power x, right, times acceleration due to gravity g to the power y times the critical depth ycr, right? So now what is our x? Minus 2 divided by 5. Minus 2 divided by 5 times g 1 divided by 5 times y critical, right? So then what is phi 2? So we can nicely write phi 2 as, no, here just focus this 1 over 5 power, right? So that you can consider in this format. Let's focus, right? G to the power 1 over 5, keep at the top. Q to the power 2 divided by 5, right? Because at the upstairs, right, here we have minus 2 divided by 5, right? So now we can shift this guy to downstairs. So that means it will be 2 divided by 5. Okay, times y critical. Right, so now we can take this 1 over 5 as a factor, right? So g divided by q squared to the power 1 over 5 times y critical, right? So this equals to phi 2, right? Hope you have taken these answers.